Okay, we're ready to begin the Lesson 14 worksheet. So in front of you, make sure you have your periodic table and we'll go through it together. So we're looking at stable and radioactive isotopes, and what they've done here is they gave us a chart, like a little blow-up corner of that chart we were just looking at, with our neutrons on the left-hand side going up and our protons going across the bottom. And you're going to remember that protons are the identity of the element. So we always want to look down here first when we find the identity element. So the first thing they're showing us is hydrogen. They've got it at 1 and 1. And so there's a hydrogen at 1 and 0. There's a hydrogen at 1 and 1. And there's a hydrogen at 1 and 2. So they're all forms of hydrogen, because if you look at their atomic symbol, this is hydrogen 3, 1 proton and 2 neutrons. That makes sense. Hydrogen 2, 1 proton, 1 neutron, and hydrogen 1, which has, actually this should say 0 right here. Well, it has 1 proton and has a mass of 1, so it has our 0 and 1 will be 1. So that's the only element that has no neutrons, the hydrogen 1. So we identify them by the protons, so that means they're all still hydrogen, but they're going to have different masses because they have different numbers of neutrons. Okay, so then let's look at helium. If I bring up my, here's helium on the periodic table, and so it has a number of protons of 2. Its most abundant form of helium out in nature is helium-4. That means it's going to have 2 protons and 2 neutrons. So there must be other forms of helium, but you look and see there aren't. So when we go to look, there's 2 and 2. That's the only form of helium that's out there, is helium-4. So when you go back to the periodic table, you can tell that, because look how it's 4.00. There's not another form of helium out there. Okay, so let's look at the next one. They want us to guess what this is. So the very first thing is, this is the identity, has 3 protons. Go back to your periodic table. 3 protons is lithium. So right off the bat, you know that these 2 that are showing up here are going to be lithium. I'm going to try to write in here. This may not go so well, so we'll see, because I'm writing with this little pencil thing and it's definitely not easy. So this is lithium and this is lithium, and we know that because there's 3 protons. So if we're going to do the same exact thing and write symbols for these like we did, we know that the bottom number is the number of protons. So we'll write a 3 here. Wow, that's a really bad 3. And a 3 there. So hopefully you guys are writing these and not waiting till we're all done, because you won't be able to read my writing. So 3 there and 3 there. Now, the atomic mass is the protons and neutrons together. So for this one, there's 3 protons and 3 neutrons, so atomic mass will be 6. That so doesn't look like a 6. Oh well, you get the drift, right? I'll try to take it out of there. I'd probably be better off typing in there. That's better. And then this one's 3 protons and 4 neutrons, so this is lithium 7. So at this point, you should be able to see, if it's not the number of protons that's changing, and it can't be the number of protons because that would change the element, then the mass must be changing because of the number of neutrons, and that number of neutrons increased here. Now, if you ask yourself, well, there's 2 forms of lithium, which is the one that's out there on Earth, easiest to find, most abundant? There's lithium 7 and lithium 6. So we go back to our periodic table, and we see that if we round this number, 6.94, it is closer to 7. So lithium 7 is the most abundant form of lithium on Earth. And I'll put a little star here and a little star over here. And you might want to write this. And I'll just write most abundant. You hopefully have better writing than this. Wow, that's really bad. Okay, most abundant. So that's the most abundant form. Okay, so now we go and find what is the element that has 4 protons. So when I go back here and I look, it's beryllium. So we're going to write beryllium in here, RBE. And I'm going to give you guys a second to finish its symbol. Okay, I'm going to give you a second to finish the symbol. In order to finish the symbol, you want the number of protons down here, and you want the entire atomic mass up here. Okay, number of protons obviously is 4. And if protons and neutrons together are atomic mass, then it should be 9. And you can look at the periodic table, and you see that beryllium has very close to an average atomic mass of 9. There is another form of beryllium out there, and it has more neutrons than this form, because this form is going to round to so that we would have 5 neutrons, 4 protons. There must be one with 5, or 6 of them rather, but we're not going to have that on our drawing. So they're only having you do. So this one right here is the most abundant form of beryllium. Okay, I'm going to give you a few seconds to figure out this one. Whatever it is has 5 protons. Okay, so your atomic number of 5 is boron. The letter for that's a B. Both of these will be a B. Because they both have 5 protons. So we're going to put our 5, because that's part of our symbol. It goes on the bottom. And then on this one we have 5 protons, 5 neutrons. That means atomic mass is 10. We add both of those together. This one has 5 protons, 6 neutrons, so we'll have atomic mass of 11. Okay, figure out which one of these is the most abundant form and put a star by it. Which one's the most abundant form of boron? So you go back to your periodic table. Here's boron. So ask yourself this question: is boron 10 or boron 11 the most abundant form of boron? Well, if you look at this number, you round it to the nearest whole number, it's going to be 11. So boron 11 is the most abundant form. I just had you doing that because making those little, they never asked you for the most abundant form right now, but I want you to get used to doing that because that question is going to come up a lot. So they filled out carbon for you. Carbon had 6 protons, and so we have a form of carbon with 6 and 6. That's carbon 12. We have a form of carbon with 6 and 7 neutrons. That's carbon 13. And then we have carbon with 6 protons and 7 neutrons, and so, 8 neutrons, and so that's carbon 14. Now, look at your periodic table and tell me which form of carbon is the most abundant, 14, 13, or 12. Here's carbon. Most abundant form, 14, 13, or 12. Well, if you look at this number, you round it to the nearest whole number, it's carbon 12. So we're going to put a little star by there so you guys can just remember. Carbon 12 is the most abundant form. The other thing I want you to see on here, and we didn't write them in on the ones we wrote in, but this is how you write it if you're writing out the name. Carbon-14, carbon-13, hydrogen-3. And so that after the dash is the mass. Okay, so when you're writing a symbol, it's the symbol, mass, then number of protons. If you're writing a name, it's the name written out with a dash and the average atomic mass. Not average, I'm sorry. The atomic mass goes right there. Okay, so let's look at what it says down here. How many isotopes does hydrogen have? How do they differ? So all you got to do is look on this line. How many different forms of hydrogen are there? That's pretty simple, right? 3. And then how do they differ? So if they all have 1 proton, and don't say it's their name or their symbol. They're wanting to really know what makes it different, and we're talking about numbers of particles. So they all have the same number of protons. It's the number of neutrons that differ. Okay, so number of neutrons. And by the way, it is totally acceptable to write, you don't have to write this out. They differ in the number of neutrons. This is fine, number of neutrons, as long as you know what you're writing. Okay, if you had a sample of beryllium, would all the items be identical? What about a sample of lithium? Explain your answers. Okay, so I'm kind of not crazy how they asked you this about beryllium, because the problem is they're only showing one form of beryllium on here, but we know there must be more than one form because the average atomic mass is 9.01. They're showing us beryllium 9 on here, but because there's that 0.01, there must be another form of beryllium. And then it says, what about samples of lithium? Explain your answers. And so when you go back and look at lithium, you can easily see that there's two of them with two different masses. So for beryllium, and I'm not going to write this in on number 2 because it will take a while, so you can pause it after I explain this. But if you have a sample of beryllium, would they all be identical? Well, if you've got an average that's 9.01, they can't be all identical. Your average has a decimal point. That means that there's going to be more than one form. What about the sample of lithium? Well, you can see that there's more than one form, and you can easily see that they have two different numbers of neutrons in them. So that's what you're going to write down here. So go ahead and hit pause, think about that, and fill it in. Okay. We're on the second part of it, and number 3, it says, next to the chart on the first page, draw a simple atom model of beryllium. And I'm not going to switch back to that one, but you guys can draw that. I'm going to draw my nucleus of beryllium, and you could draw it here on the front, whichever works for you. They had some other ones drawn on the front, so that's why they had it, but I'm going to bring beryllium up for a second. That means in beryllium we have an 4 protons, and because this is 9 minus 4 is 5, so we have 4 protons and 5 neutrons. So I'll put my 4p and 5 neutrons. And if I have 4 positives, I'm going to have 4 negatives. So it just so happens I have 2 on the first level and 2 on the second level. Okay, so that totals 4. And if you look at your periodic table, that makes sense. Beryllium is in period 2. That means it has 2 orbitals. And so that's how we ended up with 2 orbitals, 2 on the first and 2 on the second. Okay, we are on part 2, all the naturally occurring isotopes. So what's going to happen on this one, you're going to be looking at the chart, and as you look at that chart, you will hit pause after each one of them and do your answers and come back to it. Because I'm going to if I were there, I'd probably walk you through most of this anyway. So, really take advantage of the fact that I'm teaching this to you, because when I come back, I am going to ask. I'll feel free to ask anybody to help with explaining this, since we're going to walk through it. Okay, so you have to have that chart in front of you now, and we're going to go through it. Let me make sure I have it in front of me here. Yeah, I do. Okay, so when we look at the chart, they have phosphorus has 1 naturally occurring isotope. Write its name and symbol. Now, when you look at the chart, there's no names on here, just numbers of protons. So we really have to go to the periodic table, find phosphorus, which is here. It has 15 protons. So we come across here, here's 15. When we go up the line of 15, I only see 1 on the line. Okay, and it looks like it has 15 protons and 16 neutrons. So if you look at the atomic mass, phosphorus should be close to 31, and that's exactly what it is. Okay. Now, keep in mind, because it says 30.97, there must be other forms of phosphorus, but they're not showing it to us on there. So when we go back to look at phosphorus 31, we see, remember phosphorus is at 15, there it is. It's a black one, which means it's the most abundant isotope. So they gave us phosphorus 31, 15, and 16. So what's our question? Let me go back to this. Phosphorus has one naturally occurring isotope. Write its name and symbol. So if you're going to write its name, remember it has to be phosphorus. And you guys, I hope, are writing this a lot faster than me. Should be printed. And remember, then there's a dash and then 31 because we add the 15 protons to the 16 neutrons. And then its symbol is going to be a P. The 15 goes at the bottom because that's its number of protons. And the 31 goes at the top because that's its a total mass. Okay, so what I want you to do now is look on that chart and figure out which element has the most isotopes. How many does it have? So if this is an isotope chart and it's telling you, and I'll have to back off this a little bit. Okay, so if this isotope chart's telling you how many isotopes of each element there are, these are the identities of the elements down here. You're really looking for something that has the most squares going up, the most squares going up and down on this chart. So obviously it looks like it's going to be somewhere in here. So I'm going to let you guys just go ahead and count that. Find one, count it, and you'll write the answer in on this one yourself. But it says write the isotope name. Which element has the most isotopes? How many does it have? So you're just naming it, and then you're writing how many it has. So go ahead and hit pause. Find the one that has the most squares, and they could be of all colors on the line. Go ahead and hit pause. Okay, you should be back for number 3 now. Write the isotope name and symbol for the most abundant isotope of nickel. So again, because our isotope chart doesn't give us names, only number of protons, we have to go to the periodic table, find nickel, which is right here. Nickel's number 28. So now this one, and we're going to have to bring ourselves in on this a little bit. Here's 25. So I'm going to go up 25. This must be 26. Let's see what I'm going. 26, 27, 28. This is 28 right through here. Okay, and if you look on 28, we see 1, 2, 3, 4, 5. So it looks like there's 5 different forms of nickel. The one with 28 protons, whoops, sorry about that. The one with 28 protons, that's where we are right here, 28, and 30 neutrons is the most abundant form because that's the one that's black. Then it's got 1 radioactive form in white, and then it's got 3 other forms. So total numbers are 5. So what's our question again? Write the isotope name and symbol for the most abundant isotope of nickel. So we're going to write nickel. Make sure you spell it right too. And then a dash. And let me go back to that. And this is nickel 28 right here. So it's at 28 and 30. So that's 58. So we'll write nickel 58. And then you guys can go ahead and write the symbol for it. Remember, it'll have the symbol Ni. On the top will be your 58, and your number of protons will be at the bottom. So go ahead and hit pause and finish that. Okay, we're on number 4. Do you expect to find an atom with 26 protons and a mass number of 52? Explain your thinking. Okay, so we can actually just go look at the chart for that. But 26 protons is a lot of protons to have a 1-to-1 ratio. Isn't that a 1-to-1 ratio? So they've got, if you have a mass of 52, we have 1 proton for every 1 neutron. So let's go look at the chart. And that's what they're asking you to do it without even looking at the chart. But you can kind of think of that. When you start to get to those higher numbers of protons, we may not have that 1-to-1 ratio. And then the other thing I told you at the very beginning, this line is a 1-to-1 ratio. So let's look and see what our last 1-to-1 was. 20 and 20. So there's nothing at 26. Okay, so 26 would be right in here where you had that 1-to-1 ratio. So when you look at the line that shows you the 1-to-1 ratio, the 1-to-1 ratio ends at 20 and 20. So think of your reasoning there. It says to expect to find an atom with 26 protons and a mass of 52. Explain your reasoning, and you're going to say something like the 1-to-1 ratio ends at 20 protons, 20 neutrons. And so if you have a mass number of 52, then that means we've got 26 protons and 26 neutrons. That's too large. Okay, I'll give you a few minutes to write that. Go ahead and hit pause. Okay, number 5. Imagine that a chemist is trying to establish whether a piece of rock is from a meteorite that fell from outer space. The rock contains more copper-65 atoms than copper-63 atoms. What can you conclude? Okay, remember that the chart we have shows us the most naturally occurring form of copper on Earth, the most abundant form of copper on Earth. So if that meteorite was just something that came from outside of Earth, then and it contains copper-65, all you have to do is check the chart. If Earth is something different than copper-65 as the most abundant form, then that meteorite had to come from outer space, that the rock couldn't be from Earth. It had to have come from outer space. So think about that. If it's from Earth, you have to look at that chart, find the most abundant form of copper on Earth, and then compare it to the rock that the chemist found. And if it's something different from the most abundant, then it's quite possible that it was from a meteorite. Take a few minutes, pause, and answer that question. Number 6, where on the periodic table are the majority of radioactive isotopes found? Write the isotope symbol for one example of a radioactive isotope. Okay, when we go back to reading our isotope chart, remember that, let me bring this over here a little bit, radioactive isotopes have white squares. So I'm going to back off of this again so we can look at it more easily. So start looking. Down here, not so many white squares, and as we go up, there tends to be more. So look on the chart. Where's the most of them? Where do you see most of the white squares? And you don't have to give exact numbers. You can say middle of the chart, lower chart, right-hand side. Give an answer like that. And then the other part of it says, write the isotope symbol for one example of a radioactive isotope. So what you're going to have to do is go to the chart and identify one by its number of protons, and then add the protons and neutrons together. Write I think they're asking for the name and the symbol. Let's see, I'm kind of lost here now. They're asking for just a symbol. Okay, so you can write just a symbol on that. So go ahead and hit pause. Number 7, which elements have isotopes with the same number of protons and neutrons? We talked about this before. Where are you going to find equal numbers of protons and neutrons? Think about the chart. There's something on that chart that gives a clue to the same number of protons and neutrons. So you can either describe it by that clue they give you or an area on the chart. Go ahead and hit pause and finish that one. On number 8, it says list 4 types of general information that you could obtain from the isotope graph on the handout. So when you bring the graph back up, I want you to think about not just the obvious things that you see, but your keys and your labels are a big key to it. And then they've given you something else on this chart to look at. So give me 4 pieces of information, 4 types of general information that you can obtain from the isotope graph on the chart. And we're not going to do number 9 on our paper. I don't really like that question. I'll explain it to you when we're back together. But you guys are going to quit at number 8. So as soon as you finish that, make sure your name's on the paper and hand it into the sub. Have a good day, everybody.